hello, Mr. Ryan, right? We are given these multiple arrays. Yeah, each array contains the distinct number. Distinct is another way of saying unique numbers, right? Yeah, distinct, unique. I want to find out which element appear in most of them, in all of them. So that's what intersection is. Okay, can you give me the answer for this? The which? Four. Okay. Yeah. Any more?
3, 4.
Yeah, 3 and 4. 3. Okay, so basically you need to tell me the answer is 3, 4. It needs to the numbers needs to be in increasing order, okay? Ascending order, okay? So easy, yeah? Okay? Yeah? So to repeat, we are given multiple arrays. We want to find out which elements, which numbers appear in all of them in sorted order. Let's call it intersection. Intersection of multiple arrays. Please know that all these array contains distinct, unique numbers. Meaning, look, it's all unique.
Distinct, yeah? Not distant.
Distinct, yeah, unique numbers. Yeah. So when we talk about this unique thing, yeah, this unique thing. So if I draw this diagram, what kind of data structure can you? Set. Exactly, we're using set. So we can just use a set. Yeah, we can construct a set from what first array, and then we can do the intersection. Yeah, by each of it, right? Define intersection of multiple arrays. Okay. We're given these nums, which is the list of this. Now look, if we are given an empty array, then we just return an empty list, right? Return an empty list. Otherwise, let's say A is the first set from the first list, nums here. Then we just have to do for I in nums. We start from the second. Yeah, from the second list. A equals A dot intersect. Yeah, there's a function. There's a method for the set in the set I, right? But I, this is a list, so we have to convert it to a set I. So this is the same thing as A equals A and set I. Okay, this is the same thing. Okay? And then return sorted. We want to convert it to the sorted list, sorted A. Right? Look, easy. Yeah. So to sum up, we are converting the list to a set. So look, if the first list is what? If first list is 1, 2, 3, 4, 5, yeah, 1, 2, 3, 4, 5, and the second list is 1, 2, 3, 4. So 1, 2, 3, 4, right? So if we do the intersection, the second list will be this one, right? And then the third one, 3, 4, 5, 6, 3, 4, 5. The third list, 3, 4, 5. Yeah, and then there will be 6 here, right? Yeah. So look at these 3 circles. What are the common about it? Do we get it?
No.
Okay, so look. 1, 2, 3, 4, 5, 6. Okay. Am I right? Correct? Yeah. So which part is the common part? Which part is the common part of all 3?
4.
Yeah, exactly. Yeah, 3, 4. Look, 3, 4. This part appears in all the 3 arrays. That's what we got, right? Make sense? Okay, so now this is the set. We can also use the counter. Yeah, remember what's counter?
So,
What's counter? Dictionary, exactly. So we count. So we can count how many numbers, each number. Yeah, and then we go through each number in a dictionary, and then we count how many times they appear. Because each array is only contains the unique numbers. If we do this counting, if it appears n times, then it appears in all of the arrays, right? Then we can do this. Define. Okay, so this is nums. So at the beginning we have a c dot equal counter. Yeah, we don't need to give anything, so it's an empty dictionary. Okay, so then now we for I in nums. Then we can use the counter to update. You know which update? Which is the incremental changes. We takes the changes from another set. So c dot update. Yeah, c dot update count I. Okay? Yeah? Now, C contains the frequency of all the numbers combined from all the arrays. Then we have to count each number if it appears that n times, right? So that the n equals the length of the nums, which is the number of the list. Yeah. So then we have this answer. Answer equals that. For I in C, right? In C, if Ci equal n. If it appears n times, then it appears in all the arrays. Then we answer the append I. Right? But this could be out of order. Then we have to return sorted answer. Right? This is one way, and we can make this shorter. Right? Make this shorter. So we can just return sorted. Yeah, I for ij in C dot items. If j equal n. Right? Look, all these 1, 2, 3, 4, 5. 5 lines can be converted to one line. Right? Look, return sorted I for ij. I is the number, j is the frequency. How many times this I appears? C dot items. If j equals n. Okay? What does it mean if j equals n? It appears n times. What does it mean if a number appears n times? What does it mean?
It means it is all of them.
Exactly. If it appears n times, it appears in all of them. Right? That's what it is. Time complexity. How do we find out the time complexity? If there are n lists, right? If let's say each list is n numbers and there are n lists, the time complexity will be O n n. Right? The space complexity, we're using either the counter or using the set. Right? Yeah? So what have you learned so far today? Come on.
About the
In one sentence, just to summarize.
intersection of multiple arrays like set,
How many ways did they talk about?
set,
And
and
set.
count.
Okay. Well done. Okay, well, Eric, your turn. What have you learned today and what are we trying to solve? And how many ways can we solve? Okay, just 2 questions.
Intersection of
Multiple arrays, yeah? So it means that we find out which numbers
and
appear in all arrays, yeah?
and it is 2.
2. What are those?
Counter and
Counter is the second method. What's the first method?
set.
Yeah, set. Yeah, set. What set is the data structure that contains only unique numbers. Okay, so this problem is quite simple, and the one thing we have to keep in mind is that these arrays contains distinct or unique numbers. So there are no duplicate numbers in each array, right? So if there are duplicate in each array, then we cannot use the set because we don't know how many times they appear. For the set, you only remember once, right? Right? Do you get it? Look. 1, 2, 3, 3. And 1, 2, 2, 3, 3. Okay? If we can construct the set from these two, look, these two arrays are different, right? 1, 2, 3, 3. They are duplicate 3s. They are duplicate 2 and duplicate 3. If we construct a set from each array, they both will be a set of set what? 1, 2, 3, right? So basically set is just the data structure contains only unique numbers, right? So it doesn't tell me how many times appear, but the counter will be okay, right? Counter you can, but the thing is that the counter, for the counter to work, we have to check it appears n times. If it has more than one, if each array contains more than one duplicate numbers, then this method is also not working. Okay? Make sense?
Yeah.
Okay, that's it for today. Bye bye.
Bye.